Welcome, function folks. It's lesson 2.6 on solving rational equations and inequalities. Yesterday we had a big lesson on rational equations, and indeed today is a big lesson as well. But we'll see that there's not much new today. That it's an application of stuff that we've already done in perhaps a new situation. So it's not so bad today. Several examples though. You have them all on a sheet that was given out in class, and it's got the title warm up, and this is the first question. So let's get into it. Consider this function, state the domain, intercepts, asymptotes, investigate behavior near vertical asymptotes, and sketch the graph. So this is review. This warm up question is kind of like a 3-minute review question, and we'll get into it. Well, let's see, what do we got? We have the domain. Well, the domain is, this function is going to be defined for all values except for when the bottom is 0, right? So let's find out where the vertical asymptotes are. The vertical asymptotes occur when this is equal to 0, and I'll solve that tiny little quadratic equation. No problem. X equals 4. And x equals -2. So the domain is those values, the function's undefined. So I'll say the domain is x is a member of the reals, and x can't be 4, and x can't be -2. That's the domain. Danny. Intercepts. All right, well, we can do intercepts. The x-intercept and the y-intercept. When x is 0, y is 0, and in fact that's where our x-intercept is going to come from. But we've been fooled by this before, so let's check it just in case. Calculation here. When y is 0, are we going to get more than just the one x-intercept? And I can multiply, as long as this thing's not 0, I can multiply, and I get 0 equals -4x. Divide by -4, x equals 0, so it's the 1 point. That's too bad. Usually we get another point on there. Any asymptotes? Okay, so we've got the vertical asymptotes. What about the horizontal asymptotes? Well, in an investigation earlier on, we sort of compare the top and the bottom, and the bottom is bigger degree than the top, so we know the horizontal asymptote is y equals 0, and we are done. So we're going to investigate the behavior near the vertical asymptotes as well. Once we get going here. So let's see. I'm gonna actually do the sketch here. X equals 4. Get rid of this. X equals 4 -2. And vertical or horizontal asymptote of y equals 0. I should be using a ruler, and you're using a ruler, of course. And then the 1 point here, which seems strange because, usually it's this sort of thing or this sort of thing, or we're not sure. So we do have to investigate the behavior near the vertical asymptotes. So let's do it. I will go left to right. Why not? When x approaches -2 from the left, what's going on with this function f of x? And I like using the factored version to investigate this. So when x is close to -2 but a little bit smaller, I see a negative times a negative is going to be a positive on the top. -2-ish -4 is a negative over a negative, and this is where I'm going to get my teeny value when it's close to -2. So it's a little bit smaller than -2, so -2.1-ish. This is the teeny negative, which makes that a big positive, right? Because I got 2 negatives on the bottom. This is going to be a big positive. And I think of then f at x goes to positive infinity. This one. So it's up here. Probably then what's going to happen is it's going to, because it doesn't dip down below, otherwise we'd have a x-intercept here. It's probably this then, right? So that one calculation gives me that piece of the graph. All right. What about on the other side of that asymptote? Again, there's the graph. I'm just going to do the positives and negatives now. Negative times a negative is a positive again on the top. When this is minus 2-ish, this is still a minus. But when this is a little bit to the right of negative 2, this thing's positive, right? Negative, this would be negative 1.9, so this is a teeny positive, which gives me a big negative. And I can say that f at x goes to negative infinity. And again, if you don't like this logic, you can certainly use a table of values to do that. So, and that kind of, this by the way, kind of matches what we're used to seeing, where if it's positive on one side, it's going to be negative on the other. It's not always like that, but we're used to that. Now notice what's happened here. This probably isn't going to go back down this way because it's got to go through this point. If I had to guess, I'm guessing it's going to do something like this. And if I analyze that, these are the last two that I got to do, right? Let's see what happens. And this is kind of in my head, I'm thinking about this. This is negative on the top now because 4 is positive, so that's going to be a negative on the top. And 4 is, it's a little bit to the left of 4, so that means this thing is a teeny negative. Teeny negative. This is a little bit to the left of the 4, so this is positive, and this is positive infinity. Right? So this is going to go towards positive infinity, just like I hypothesized. Now, what about over here? Is it going to go like this, or is it going to go like this? Certainly, it's not going to do one of these dip things because we have no x-intercepts. Well, let's do the analysis. Again, the top is negative. Negative 4 times 4-ish is negative. On this factor, though, if it's a little bit more than 4, is going to be a teeny positive, and then a normal positive. Overall, this is going to be a negative. So f at x is going to go towards negative infinity. And I'm going to have this idea where it trades sign on either side of the... There, dandy. Done. Review. So what's the big whoop here? Well, let's continue on into the lesson and see how we use this sort of thing. Rational equations and inequalities. All right, so there's a graph there already given to you, and we've got to do something with it. Let's read on and see what's going on. It says, part 1, using a graph to solve rational equations and inequalities. It says, label the functions f and g on the graph shown. Notice I've already done that. You should do that as well, but let's think about why. The easiest way is probably to identify the vertical asymptotes, right? This has got a vertical asymptote at 3. There it is. This has got a vertical asymptote at -1. There it is. Notice we can check that with the horizontal asymptotes. This has a horizontal asymptote of leading coefficient divided by leading coefficient, which is 1. Right there is the horizontal asymptote of f. And I can see the horizontal asymptote of g is 0, since the bottom has a higher degree than the top. It says use the graph to solve that equation. Well, we did some of these last time and we cross-multiplied and all that other business, but here we can use it graphically. Where are the two graphs equal? Where's the left side and the right side equal? Where do they cross? There and there. And again, we're not interested in the y values because there's no y values. That was introduced by us to graph the left side and the right side. We're interested in what x value makes the equation true. So it looks like x is -3 and x is 1 is the solution. No problem. Shade over the part of f at x that lies below g at x. The part of f at x that lies below. F lies below g. I'm going to read this from left to right, and we're interested in where is f at x, where's the red one on my screen, lower. Well, if I read left to right, the red one's higher, right? Higher, 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 equal. And then now, in this part, the red one's lower. Red is lower than blue. And then suddenly there's a cutoff spot, right? The blue one takes off. And then on the other side of this asymptote, the red one's higher again. So I'm not shading in this part because red is higher, red is higher, red is higher, equal. Red is lower, red is lower, red is lower, red is lower, until this blue one's higher, but the red one's lower. And then on the other side of the asymptote, the red one was higher again. So shade over the part. Okay, so we did that. That's on our graph. And it says, from the graph, write the values of x that satisfy that. Well, what x values have we shaded in here? Well, those ones and those ones. In set notation, I could say the solution set was, and notice that it's not equal to, so it's going to be -3 is less than x is less than -1. No equal to, because there's no equal to here. And I can put this is an and. I could use just a comma if I wanted to. And this chunk from 1 to 3. In interval notation, I would say x is a member of these sets. Don't include the endpoints. Like that. And that's in interval notation. Dandy, no problem at all. And I mentioned last time how we could use a graph to solve equations, and this is how to use a graph to solve inequalities. Funsies. Let's just keep going here. Use the graph from the warm-up to solve the rational equation, that rational equation. Your solution may be an estimate. So I've copied this, but you can just look up. I can't just look up on my sheet. Here's a copy of the graph, and I know it's kind of a nice copy, but what I did, there's the blue is the left-hand side. The green, and blue, green, and I mean y equals this, y equals that, is what I'm graphing on there. Your solution may be an estimate. So where is the right side equal to the left side? Well, it's where this green and blue meet here. There. And then this is going to be over top of there for all those. So it appears x is about equal to, on my graph, the way I've drawn it, and this might be an estimate because we don't know how slanty these pieces should be, but I go -1, -2, -3, -4, -5, about -6-ish, maybe, and around 1. And again, we don't know how slanty this is, so this is an estimate. It says use the graph from the warm-up to solve the rational inequality, where is the blue graph less than 0? Well, here's where the blue graph is greater than 0. That's this chunk, right? Here's where it's equal to 0. And here's where the graph is less than 0. So if I'm interested, where's the blue graph less than 0? It's this black part that I shaded in. So here it's less than 0, and here it's less than 0. So what x values am I interested in? Well, it looks like it says ask me to write it in set notation. From here to here, 0 is less than x. Oops, not 0. Starts at -2, doesn't it? -2 is less than x is less than 0. And, let's use a comma this time for funsies, 4 is less than x. And I could go to infinity. Normally, we wouldn't write it like that. We'd write it as x is greater than 4. Not greater than or equal to, greater than, because of the less than or equal to sign, and because it's an asymptote. There, dandy. Now, of course, what we're interested in is how do we do this algebraically? We don't really like these estimates, right? We like being exact in math, or at least as exact as we can. And so we're going to get into that in part 2 of today's video.